This video is for engineers who have used Cursor or at least watched the demos, but still feel like the product disappears into marketing fog the moment you ask how it really works. My main claim is simple. Cursor is not one giant chat box embedded in an editor. It is a layered coding runtime. Different loops handle different kinds of work. Tab handles local predictive editing. Agent handles deliberate multi-step execution. Cloud agents handle detached branch work. Bugbot handles pull request review. Those loops share context and infrastructure, but they are not the same feature. Once you separate them, the product becomes much easier to reason about. You can ask what context each loop sees, what tools it can call, where execution happens, what data leaves the machine, and what kinds of work belong in each path. The first useful correction is to stop talking about Cursor like it has one brain and one operating mode. The product actually exposes several loops. Tab is the fastest path. It is about predicting the next edit while you are already in flow. Agent is the slower but more capable path. It can plan, gather context, call tools, and execute work. Bugbot is another loop entirely because it runs against pull requests and tries to surface defects before merge. Then cloud agents move the execution context off your laptop and onto a remote branch workflow. Engineers get confused when they assume these are all just different buttons over the same mechanism. They are related, but they exist because the latency budget, context budget, and risk profile are different in each case. Cursor's tab docs are surprisingly revealing because they define the low-level loop very clearly. Tab is the AI-powered autocomplete. It is looking at recent edits, the nearby code, and linter signals. That already tells you this is not just token completion on the current line. It is a local editing predictor. The docs also make clear that Tab can modify multiple lines, add missing imports, and even suggest coordinated edits across related files. After you accept one suggestion, pressing Tab again can jump to the next predicted edit location. That means Cursor is maintaining a lightweight model of where the editing session is going. This is the important distinction. Tab is not trying to solve the whole task. It is trying to keep your hands on the keyboard and compress the edit loop. The agent path is where Cursor starts looking like an actual runtime instead of an autocomplete engine. Cursor's product docs say that for complex tasks, it can ask clarifying questions, build a plan, and execute in the background. It can also run shell commands directly with sandboxing on by default. That matters because the execution surface is no longer limited to text generation. It can inspect the repo, run the build, run tests, and make changes based on the result. The same docs also call out subagents running in parallel and using the best model for each task. So the engineering mental model is not one prompt into one model. It is more like a small orchestrator. Context selection is also explicit. Mentions and image uploads are there, so the user can point the runtime at the exact evidence that matters, instead of letting the agent guess. The next layer is context assembly. Cursor has several mechanisms that people tend to blur together. Rules are persistent instructions. The docs say team rules, project rules, and user rules are merged in that order, with earlier sources taking precedence on conflicts. Separately, AGENTS.md files can live at the project root or in subdirectories, and nested files combine with parents, while the more specific directory wins. That gives Cursor a scoped instruction hierarchy, but that is not the entire context system. The product page also says Cursor uses a custom embedding model for best-in-class recall across large code bases. So there is an instruction layer and a retrieval layer. One more detail matters for engineers. The rules docs say rules do not drive tab, and user rules are not applied to inline edit. That is another clue that the product is multiple loops with different context paths. This is the part many engineers either miss or assume incorrectly. Retrieval does not happen by magic on your machine alone. Cursor's data use docs say that if you choose to index your codebase, the code is uploaded in small chunks. So Cursor can compute embeddings. The embeddings and metadata, such as hashes and file names, may be stored in their database. The docs also say file contents can be cached temporarily on their servers during a request, encrypted with client-generated keys. Another easy-to-miss detail is that even if you bring your own API key, the requests still go through Cursor's backend. That is where final prompt construction happens. So when people ask how Cursor can recall things from a large repo, the answer is not only bigger context windows, it is also indexing, retrieval, and server-side orchestration. Once you accept that Cursor is a runtime, the rest of the product page reads differently. Shell commands are one extension surface, but not the only one. Cursor now talks about plugins, domain knowledge, and direct connections to external systems like GitHub and Figma. Those are all ways of extending the capability surface around the model. The right engineering reading is that Cursor is building a tool-using environment around code generation, not just improving the prompt box. This is also why the product can feel much smarter than a raw chat model in the same editor buffer. It is not only writing code, it is selecting context, invoking tools, and moving structured results back into the model loop. The model matters, but the runtime and capability plumbing matter just as much. Cloud agents make the architecture even more obvious. Cursor's Cloud Agent docs state that these agents clone your repo from GitHub or GitLab, work on a separate branch, and then push changes back for handoff. That is not an autocomplete feature. It is remote software execution wrapped in a code review-friendly workflow. The docs also say cloud agents use a curated selection of models that always run in max mode, and that they can use MCP servers configured for the team. So this is basically a detached worker tier for longer running tasks. The product page adds that you can launch agents from GitHub, Slack, Linear, JetBrains IDEs, or a browser or phone. This is a strong signal that Cursor is trying to make the agent runtime portable across surfaces, not just inside the local editor. Bugbot is useful because it shows Cursor expanding beyond authoring into review. The product page says Bugbot runs in the background on new pull requests, comments on likely issues in GitHub, and can provide fixes directly in Cursor or through the background or Cloud Agent path. The company claims low false positive rates. More than half of the bugs they find are fixed, and over 70% of flags get resolved before merge. Whether you take the benchmark numbers at face value or not, the architecture point is clear. Review is its own AI loop with a different objective function. It is not trying to continue your current edit. It is trying to inspect a diff, reason about logic, and intervene before merge. That is yet another reason Cursor should be thought of as an AI engineering workflow system, not merely an editor plugin. The trust model matters because Cursor is not purely local. The security page says code data is sent to Cursor servers to power all AI features. The data use page says that if privacy mode is enabled, zero data retention is enforced at model providers, and your code is not used for training by Cursor or third parties. But the same docs also say Cursor may still store some code data to provide features. And the indexing path we just discussed is one example. The security docs go further and describe implementation details like an X-Ghost mode header and parallel privacy and non-privacy. Service replicas. The right engineering takeaway is not that privacy mode makes the system local. It does not. The takeaway is that Cursor has an explicit privacy boundary with specific guarantees and specific exceptions. You should evaluate that boundary the way you would evaluate any other hosted developer platform. So the clean mental model is that Cursor is an AI coding runtime wrapped in IDE and workflow surfaces. The visible entry points are the editor, pull requests, and remote triggers. Underneath that, Cursor assembles context from rules, AGENTS.md, explicit mentions, and retrieval over indexed. The runtime can route work across models, and subagents then execute through tab, shell commands, plugins, external systems, or cloud branches. Review loops like Bugbot sit downstream and feed back into the codebase. Once you see the system that way, practical usage gets clearer. Small local edits belong to tab. Scoped implementation tasks belong to agent. Long-running or asynchronous work belongs to cloud agents. Diff skepticism belongs to review. Cursor is valuable when those layers cooperate well. It becomes dangerous when you forget which layer is acting, what context it has, and what boundary it is allowed to cross.